All right. Happy Friday, everybody. Today is May 8th, and I am going to be reviewing the combined lessons 35 and 36 from Eureka Module 5, fourth grade, the fraction module. The I can't statement, it's pretty lengthy today, and I don't want the length of it to kind of scare you away. I'm going to be explaining what this actually means. So the I can statement, which is the goal and the objective that you should, we hope that you reach by the end of the lesson, is I can represent the multiplication of n times a over b as n times a over b. That is called the associative property. So using the associative property and visual models. So I hope that you did watch the Dr. Dwayne video for lesson 35. Lesson 35 is, I would say, the more important than 36 at this point. Just looking to, what we're trying to get you guys to do. So I want to show you and explain to you that just because we're introducing letters in our math, I don't want it to scare you. You're going to start seeing letters to represent numbers coming up when you get to algebra, when you move on to fifth grade, and so on and so forth. Even into high school, especially in high school, you're going to be seeing things like this. So I'm going to explain what this means, because I don't want you to get nervous. So let's say I'm going to give you an example. I'm going to use 6 plus n equals 10. So if I say to you, boys and girls, please solve for n, well, you have to think 6 plus what number equals 10? Well, 6, 7, 8, 9, 10. I know my answer is 4. So we would say n is equal to 4. So see how it's not scary. The introduction of letters in math should not be scary. All right. So let's look at what this whole n times a over b actually means. All right. N is just representing a whole number. This could be any letter in the entire world. Q, R, S, anything, A, whatever. So what we're doing is we're looking at this as a whole number is represented by the letter n times a fraction, which is represented by a over b. So let's just kind of assign numbers to these letters, and I'm going to show you how it's not as scary as you might think. Here we go. Boom. 3 times 1/2. Now we know from, introduction of multiplication from last year in third grade that multiplication is a quicker way of doing repeated addition, right? Because if I say something like this, 5 times 8, right? This is what I'm really saying is 5 groups of 8. So I can represent that as 8 plus 8 plus 8 plus 8 plus 8. See how that is 5 groups of 8? 1, 2, 3, 4, 5. And, hopefully you do know it's 40. Now, isn't it much easier knowing 5 times 8 than going off to the side and saying, okay, well, 8 plus 8 is 16, and 8 plus another 8 is 16, and 16 plus 16 is 32, and 32 plus 8 is 40, right? We agree that multiplication is a faster way of doing that. So I did kind of write this out for you guys as fractions, 3 times 1/2, because I wanted to show you that 3 times 1/2 is the same as doing 1/2 plus 1/2 plus 1/2. See how this is 1/2 3 times? So we're not going to forget our rules when we add a fraction that has a denominator that is the same, right? The denominator stays the same, and all I need to do is add my numerators. 1 plus 1 is 2, and 2 plus 1 is 3. So 3 times 1/2 is 3/2. I'm going to show you that as a model now, right? Here are my 3/2. 3 times 1/2 will get me 3/2, which I hope you recognized is a fraction greater than 1, improper fraction. So, we want to kind of show that how many of those halves are equal to 1? Well, 2 halves make a whole, right? If I have a candy bar and I split it in half with Ashley, Ashley gets half and I get half. That never changes, right? So 3 halves is actually the same as 1. And how many do I have left over? 1.5. Okay, 1.5. I am going to show you guys that as a visual model because I know that is part of the I can statement. I'm going to draw out 3 halves for you guys. So I know that my model, no matter which way I do it, a circle, a square, a rectangle, is going to be split into halves. How do I know that? Well, because that's my denominator. My denominator always determines, it always tells me how many equal pieces, equal is the key, right, with fractions, how many equal pieces my whole will be split up into. And why do I say they have to be equal? Well, look at it this way. Yeah, I split it into 2 pieces, right? My denominator's 2. I split it into 2 pieces. Does that look equal to you? If I had a pizza and it was cut like this, right? And I ate this part and I gave this part to somebody in the class, would that be equal? No, absolutely not. That's why it's so important to try to draw them as equal as you can. Obviously, it's not going to be perfect, but so now I have my half, 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 half. I have 4 halves here. I only need to shade 3 of them. So watch. 1 half, 2 halves, 3 halves. So look at how we're saying that 3 halves is the same as 1 because 1 entire shape is shaded. And how much of the next is shaded? Half of it. So that's how I know that 3 halves, 1, 2, 3, is equal to 1 whole and a half. All right, so that's how I can convert my fraction representing my fraction greater than 1. That's how I can convert it over to a mixed number. So now I'm just going to take a couple of examples from your problem set. Obviously not the ones that I asked you to solve because that would be silly. That'd be like giving you the answer. I'm going to take maybe just 1 or 2 examples and show you how you can solve these. All right, just bear with me. I was erasing my board. I'm sorry. Let's take 7 times 4/9, which is from lesson 35 problem set, question 3. 7 times 4/9. Okay, I can write this out as, I mean, I'm not going to solve it this way, but I'm just showing you how many 4/9 would I have. I would need 7, right? This is read as 7 groups of 4/9. So 1, 2, 3, 4, 5, 6, 7. And I think you guys would agree that multiplication in this case is going to be definitely quicker than adding these all up. 1, 2, 3, 4, 5, 6, 7, right? I know that my denominator stays the same. Okay, look at it's all the denominator. The bottom number is the same. My whole is still going to be cut up into 9 pieces no matter how many times I have, in my numerator. So let's see how we can figure this out. 4 plus 4 is 8. 8 plus 4 more is 12. 12 plus 4 more is 16. 16 plus 4 more is 20. 20 plus 4 more is 24. And 24 plus 4 more is 28. Wow, that took us a long time. Look at it this way. Denominator stays the same. And we're just multiplying 7 times 4. Bada boom. Right? Now, if I want to change this into a mixed number, because clearly this is a fraction more than 1, because look at how big my denominator is. I would have to draw out 28/9, which that might take me a while. But, if this is the way that works for you, I would draw out my wholes, and each of my wholes would be divided into 9, right? So let's see how we can do this. Gosh, 9 pieces. This is, I'm going to try as best as I can. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now you guys might say, Ms. Lahosky, why did you draw 4? You can just draw 1 at a time and keep counting. I have, a good number sense and grasp on fractions, so I secretly know that you need to have 4. But so here we go. I'm going to start shading all of them, right? So this is 9/9, right? 9/9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. All right. here's my 28th. So we can say that 28/9 is equal to, how many holes do I have here? 1, 2, 3 holes. With how many left over? 1 out of 9. Remember, my denominator stays the same. So we just showed that 28/9, or 28/9, is equal or equivalent to 3 1/9. This is my improper fraction. This is my mixed number. I figured out what this is by drawing models and just kind of counting everything that I was shading until I got up to 28. All right, let's look at one more example, and then I'm going to end this video. Let's see what we have here, folks. Okay, let's do this one. This one's not going to take us as long, I don't think. So we have 6 times 3/5. I am not going to do it as repeated addition because we want to shy away from that type of thing. I mean, if the question asks you to show it as a repeated addition equation, you would do 3/5 plus 3/5 6 times, right? But I'm going to show you that our denominator always stays the same, and we're multiplying 6 times 3. Well, 6, 12, 18 is 18. So the answer for 6 times 3/5 is 18/5. Now, if I say record your answer as a mixed number, well, let's draw out 18/5. We're basically counting by 5s, right? If everything is broken into 5s, because that's what my denominator is, we can easily count by 5s. 5, 10, 15, 20. Now, I know I don't need 20 because I only have 18. So these are going to be divided into 5s, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now I'm going to be shading 18 of the fifths. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right. So I know I have 3 holes already. 15, 16, 17, 18. That's it. That is how we can show 18/5 using models. So I know I have 1, 2, 3 holes, and how many left over of the remaining fraction? 1, 2, 3. 3 out of 5. We know that because here's my last 2, and 3 plus 2 is 5. And that is how we can represent 18/5 as a mixed number. I hope this video helped you guys. Please let us know if you need any more help and support. We are here for you. Mwah!